we're going to start section 6.5, dividing polynomials and also with synthetic division. So there's two ways that we know how to solve these types of problems already. One way is what we learned yesterday, the day before, which is using long division. Another way was what we learned actually in section, 6.4, which was just looking at the numerator and dividing each little part by the denominator. Both things that I'm saying actually are the same thing. Like using long division is the same thing as dividing each little part by the denominator. Let me show you the difference in solving something like the polynomial in letter A. So before we learned long division yesterday and the day before, if I said simplify this, what you would do is take 12x squared divided by 4x, and basically separate it, and then minus 20x over 4x, and then plus 8 over 4x. This is the only method we knew how to simplify before we learned the long division method. This would only work when you have one single term and it's not like 4x plus 1. If it said 4x plus 1, you can't do this method, so it doesn't always work like the long division method does. If I was going to simplify this, then I would look at each separate part and simplify everything that I can. Coefficient numbers, pull out factors, variables, take away variables that can be taken away. So like 12 and 4, I can take a factor of 4 out of 12 and a factor of 4 out of 4. I'll be left with a 3 on the top and a 1 on the bottom. X squared over x to the first power. We can use the quotient rule. There's 2 up top, 1 on the bottom. 1 on the top will cancel out with this 1 on the bottom, so this will go away, and I'll be left with just x to the first power at the top. So this ends up simplifying to just 3x over just 1, or just 3x for the first one. And then for the second one, looking at the coefficients, 20x over 4x is technically a negative, so if I'm looking at the final answer, I know it's going to be minus. But 20 and 4, I can pull out a factor of 4 out of the 20. That will turn into a 5. I take a 4 out of the 4, it turns into 1. And then both of these x's cancel out since I have 1 on the top and 1 on the bottom. So the only thing left is just minus 5 over 1, or just 5. And the last little fraction, 8 over 4x, the only thing that I can do is take a factor of 4 out of both 8 and 4. I can divide 8 by 4, it turns into 2. I can divide 4 by 4, it turns into 1. What I'm left on the top is a positive 2. On the bottom is 1x. So technically, if I use this simplification process, I'll be left with 3x minus 5 plus this 2 over x thing. This is the only method that we knew about before I introduced you to the polynomial long division. Polynomial long division can be used all of the time. If I was to solve the same exact problem with the long division, I'm going to try and squeeze it in this area here. I would set it up, put the 4x on the outside, and put the 12x squared minus 20x plus 8 on the inside. And then I follow the process in which this is going to be easier since there's only one term here. It's not like 4x plus 1 where you have to do a couple things. You first would just figure out how many times does 4x go into 12x squared. And that would be 3x times. You line it up here. You would put the 3x right here. 4x times 3x is 12x squared. And you're going to subtract. These are going to cancel and become 0. And then you would bring down the minus 20x plus 8. Then you would do the process again, but now you're looking at how many times does 4x go into a negative 20x. So this I know, if in order for this to turn into a negative, I know it's going to be a negative, so minus here. And it's going to just be a minus 5 because 4x times negative 5 would be negative 20x. Then I would do 4x times negative 5. I get negative 20x. And when I go to subtract, these also cancel out. I bring down the 8 and start this process again. And this is where it gets a little bit confusing because 4x can't go into 8. So this is going to be our remainder. And when we have a remainder, we always either add or subtract it, depending on what type of number it is. It's a positive 8, so our final answer would be all of this plus 8 over 4x. which then we would do the same process that we would in the first one, is simplify this by dividing this and this by 4, and you're going to be left with a 2 on the top and 1 on the bottom, which means the final answer would be 3x minus 5 plus 2 over x. So this process can be used.
Wait, is the denominator always going to be the monomial that you're dividing by?
Yes, yes. So this process can work all of the time. You might prefer what I just did to what I did here because it's been a couple of weeks maybe since I taught this, and it only works sometimes. The long division process works every single time. Depending on what you prefer, I want you to pick a method and try letter B and letter C. So if you prefer the long division method, then you would set this one up, put the m here, and put the m to the 4th power plus 2m squared minus 7, and then use the long division to simplify this. If you understand the cancellation method, then you would just write it in fraction form and cancel out what you can cancel out, and then whatever you're left with is simplified. So I'm going to give you a couple minutes, try B and C. We'll go over the answers, and then we'll move on to a new method, which is called synthetic division. So put it on n to the 3rd power, and there is no n to the 3rd power, so you can put it over there. This one is a little confusing because of the spacing of that one. Don't know if you're confused. B, and C, and depending on the method that you prefer, your process will look a little different, but you should get the same answer in the end. So if you prefer the long division method, then it just will take a little bit longer to get to your final answer, especially because this one, when I go to write it out, I see that we have m to the 4th power, and then it goes down to n to a squared. So it's really helpful. It's not necessary, but it's helpful to use these place savers so you don't lose track of what's going on here. And you would need 2 place savers, a 0m to the 3rd power, and also a 0m, which requires a lot of things to write here, just in case you lose track of what needs to be subtracted and whatnot. Not necessary, but it's helpful. So if you like the long division method, then to do this process, m goes into m to the 4th power, m to the 3rd times, so you would line it up there. If you don't use the place saver, then you can just put it like in the middle of the 2 terms there. M times n to the 3rd power is n to the 4th, you subtract, and then these cancel out, and whatever you're left with, you would bring down. Like, you don't necessarily need to bring down the 0m to the 3rd because it's just 0, just there for a place saver, but if you want to bring down the 2m squared plus 0m, you don't even need to use this place saver either, so I don't even need to. I'll just put the minus 7. Okay, then I would figure out how many times m goes into 2m squared, and that would be plus 2m times. So I'm going to line it up here, plus 2m. m times 2m is 2m squared. I then would subtract. These cancel. I can bring down the negative 7. And m does not go into negative 7, which means that negative 7 is the remainder. What we have as our answer is up here. This is the total answer that can be completely divided out. M to the 3rd power plus 2m, but we will have a remainder, and the remainder will be minus 7 over m. So that's how you would use the long division to get to that answer, which I think does require a lot more work. If you like the simplification method better, then you would line it up or set it up as m to the 4th power plus 2m squared minus 7 over m, and then just cancel out things that you can. You can split it all up into m to the 4th over m plus 2m to the 2nd over m minus 7 over m if you prefer. Some of you might understand that that's what works, but that's what's happening. You don't have to do that step. This is just showing more work. And then you could cancel it out by looking at m to the 4th power minus m to the 1st power would be m to the 3rd. 2m squared over m. This m will cancel out with one of these m's, so I'll be left with just 2m. And then 7 over m can be simplified, so it would just be minus 7 over m. So whatever method works for you is fine with me. It really is up to you. And then letter C. Erase all of this. I honestly feel like the just like simplification method is quicker in this problem, so I'm just going to do that so we can move on. When you're doing that, you're basically simplifying this first. 18 over negative 6 is negative 3. C to the 4th power over C to the 1st power is going to be C to the 3rd power. Once you have that simplified, then you can divide out the other side, and that's going to be negative 24c squared over negative 6c. That'll be positive 4. C to the 2nd power over C to the 1st power will just be C altogether, and then that would be your final answer with no remainder. Okay, so that's using long division to simplify and also using just like regular simplification methods with division and dividing out factors. The last thing that we have in section 6.5 is synthetic division, and this is a weird process. I literally have no idea how it works. I'm not just saying that. Like, I don't know how it works. It's like magic. And I'm cool with just knowing that it works and just going with the flow. And like the video that I'm going to be sending you tomorrow, even like Sal from Khan Academy has really no idea how it works. He says the same thing. He says it's like magic. But it's like requires not a lot of work. But the method I'm going to teach you only works for specific problems that I'll show you what it is in a second. So a lot of times on our note packets, there's like all of these words and stuff. It's basically like just right from the textbook, which is great, but sometimes like reading stuff is really hard in math. So instead of just like reading this to you and showing to you, I'm going to do the same problem again next to it so you kind of see a bit, like you can watch me do it, and then if you're confused, you can rewatch this part of the video later. So here's the problem that we're going to be doing. It's x to the third power plus 3x squared minus 4x minus 10. We're dividing all of that by x minus 2. With long division, we would set this whole thing up by putting the x minus 2 here, and then we would put x to the third power plus 3x squared minus 4x minus 10, and we would start the whole process, which takes a long time and a lot of work. Synthetic division is this weird algorithm that somebody somehow made up, and it works. It only works when you have a plain x number here and a plain number here. Like if you had x squared minus 2, there's a different process. But for all the problems in section 6.5, we're always going to be dividing by a plain x number plus or minus with another plain constant, so it will work. And here's what you do. You draw like this, like almost like one half of a rectangle, like a little line and a long line here. And for whatever reason, you look at this number and you write the opposite of that number right here. So I'm going to write a 2 right here. It's a weird thing you just have to memorize. And then the next thing that you do is you write the coefficients of the long polynomial that's being divided by all in a row here. So this is 1x to the third power, so you have to write a 1 here. This is 3x squared, so we write a 3 here. This is negative 4x, so we write a negative 4 here, and a negative 10 constant, so we write a negative 10 here. If there ever is a polynomial that skips an exponent, like for example, if it said x to the third power plus x plus 1, you would have to insert a 0 anytime you skip one of those place values, or it'll mess the algorithm up. And I actually didn't write enough space underneath my numbers. I wrote a little bit too big. Sorry, you guys, to erase something. We have to fit another row of numbers down here. So if you just did the same thing I did, make a little bit more space so you can fit more numbers underneath. So here's how the algorithm works. For whatever reason, you take this first number and you just write it down here as your first number. And then you do this weird process about multiplying and adding different things. So the first thing that you do is you multiply 2 times this number down here. So 2 times 1 is 2, and you put it here. And then you take these numbers and you add them. 3 plus 2 is 5. And then you do the process again, but now you're using the 2 and the 5. You multiply 2 times 5 and you get 10. And then you add the negative 4 plus 10 and get 6. And you do the process one more time. 2, but now times 6 is 12. And then you look at these numbers here. Negative 10 plus 12 is 2. You write that down. This last number, however it happens, this last number all the way to the right, no matter how many numbers there are, the last number is always the remainder. Always the remainder. Sometimes it'll be 0, and that means there is no remainder. But whatever number that is the remainder of the problem. And the rest of these numbers are the coefficients of the answer. So I always start here. This last number, no matter how many numbers there are, this is always going to be your constant. And then this number here is going to be the x. This number here is going to be the x squared, and if there were more numbers here, it would be x to the third power, x to the fourth power, and so on. So it basically starts with a constant number, and it works its way up into however many numbers you have in the problem. That's the number of exponents the x would need. So basically, what our answer is, since we have 1 here, that means that we have 1x squared as our answer. Since it's a positive 5, we would put plus 5x. Since it's a positive 6, just plus 6, because that's the constant number. And this is our remainder. Our remainder is a positive 2, and just like the long division, we have to put the remainder over the original divisor. I know this is the random number we have in the beginning, but what's actually being divided is x minus 2. So we have to put that there as the answer. So I have no idea how it works, but it works, and it's so much easier. You just have to remember the weird algorithm and then what these numbers represent, and then there's your answer. Okay, so we'll try another one. On the next page, we're going to try this example too, just so that we can see what's going on with these solutions. So here we have, we're dividing this. So we're dividing x to the third power minus 7x plus 6 all over x minus 1. Sometimes these problems will be given in this format. Sometimes they'll be given horizontally with a division sign. Yep?
Does it always have to be an x with another number, or can it just be like a single x?
So if it's a single x, then you're not going to want to use synthetic division. You're going to want to use either just like dividing things out or use long division. This only works if it's like x minus a number or x plus a number. But great question. So here's a perfect example of when we need a place saver and when we don't actually get a remainder in our answer. So to set up the synthetic division, what we need to do is draw this like half of a rectangle thing. And we put the opposite of this number right here on the left. So I'm going to put a positive 1 right here. We're going to have two lines of numbers. The line of numbers up here are going to be the coefficients, which are the numbers in front of the variables, going all the way down. We start with x to the third power. That's 1x to the third power, so I would put a 1 here. We're missing the x squared number, so because it's not there, we need the 0 as a place saver, or the whole thing will get messed up. Negative 7x is next, so this would be a negative 7, and then 6 is the constant would go here. And then here's how the algorithm works. You write this first number down here, you just draw the arrow down, you write it down, and then you start the multiplication and addition process. 1 times 1 is 1, so you put a 1 here. Then you add 0 plus 1 is 1. Now you start with this 1 and this 1. 1 times 1 is again 1. And you add negative 7 plus 1, that's negative 6. And then you do it one last time. 1 times negative 6 is negative 6. 6 plus negative 6 is 0. This last number is always the remainder. Then working our way up, this is going to be the constant number. This is the x number, and this is the x squared number. And if we had more numbers, it would be the x to the third number, x to the fourth number, and so on. So then your final answer, you put these coefficients in front of whatever it is. So this is going to be 1x squared plus 1x minus 6. There is no remainder, so you don't need to write plus 0 over x minus 1. I mean, you can if you really want, but you don't have to. Now this problem has no remainder because these are one of the types of problems that in the last section before spring break, I would have said, you know, factor this and simplify. But because we don't have to do that now that we have this new method that I think is easier than factoring, you can use this every single time and not have to factor anything. You just have to remember the process. Yep. Yep. All right, so do you want to try one more? Do you guys think that you get it? One more? Okay, let's do one more together, and then I'll have you guys practice on your own.
Sorry it took so long. I was in this room.
Okay, thank you. All right, so here's the next problem. So we're going to set it up by writing this rectangle thing. Whatever we're dividing by, that number there, you write the opposite of it right here. And then the numbers you write in here are the coefficients of the numbers up here. So this is going to be 1, 1, and negative 6. We don't need any place savers because we go from x squared to x to the constant. Once we have it set up, we take this number here, rewrite it down here, and the process can start. We do 2 times 1 is 2. We write it there, and then we add 1 plus 2 is 3. Then we do 2 times 3 is 6, put it there, and add negative 6 plus 6 is 0. This number here is always the remainder. We don't have a remainder in this problem. This is going to be our constant. You don't have to write this each time, I'm just kind of showing you. And the next thing after the constant is the x number. So what will just the final answer be for this one? Yep, the answer is just x plus 3. that originally, when we learned how to factor way back when, I would have given you this problem since it works out perfectly. I would say simplify, and you would be simplifying this into x plus 3 over x minus 2 over x minus 2, because that's what this factors out into be. You would have canceled that out, and you would be left with x plus 3. Now you don't have to factor, you can just use this method. Yep?
Wait, why'd you put a 0 in the last one?
Because negative 6 plus 6 is going to end up just being 0. So I don't have a remainder for this one.
No, I mean like the last one you put like a 0 after, you put a placeholder.
Because it went from x to the third power plus x. It was missing the x squared.
Okay.
So if you ever need a placeholder, if it's missing one of the exponents, you have to do that. So for example, this next one you're going to try on your own, x to the third power minus 4x plus 7, that exact thing will happen. You need a 0 in the x squared position. So go ahead and try letter B. And if you're up for it, try letter C. Yep. So and see how it goes from x to the third power down to just between x. It's missing x squared. You need a 0 in between the 1 and the 4. And that's going to be a negative 4. Yep.
I'm really confused. Can you help me?
So the process, because you missed when you were out, is that you look at what you're dividing by. We're dividing by x minus 1, and this weird process is, for whatever reason, this number here is minus 1. You take the opposite of minus 1, which is positive 1, and you put it right here. So write a 1 right there. Okay.
And what happens to x?
Not needed. I don't know why, literally. So what you're doing now is you're taking the coefficients, which are the numbers in front of the variables, and you're listing them here. So 1x to the third, and you need some space. So actually, like, you need 2 rows of numbers. So, yeah, so there you go. So 1, and then it's missing an x squared, so you're going to have to use a place saver of a 0. Put it next to it a little bit to the right. There you go. And then x is next, and this is going to be a negative 4, and then positive 7. The algorithm is weird. It's random. You have to memorize it, but it's super easy once you do. You don't have to do any long division. You take this number, and you write it here. You take this number and this number and multiply them. 1 times 1 is 1. You put that here. You take 0 plus 1 and add it, and it's going to end up being 1 anyway. You take this number and multiply it by this number. 1 times 1 is, again, 1. You put it here. You add negative 4 plus 1 and get negative 3. Do the process again. 1 times negative 3 is negative 3. You put it here. You take 7 plus negative 3, add them, and you get 4. Now this is your answer. You just have to understand what the answer is. This last number is always the remainder. This is always the next one to the left of it is going to be the constant. The next one left to it is going to be the x value. The next one left to it is going to be the x squared value, and it can continue on if there are more numbers. This means that this is going to be x squared plus x minus 3 with a remainder of 4.
Alright, wait. X squared. So wait, how'd you get the x squared?
Because what happens here with these problems is that the last number on the right is always your remainder. This one here is always going to be the constant next to it, to the left of it, constant. This one here, as the constant gets bigger, it turns into just x. As that gets bigger, it turns into x squared. If there was another number here, it would be x to the third, it would be x to the fourth, x to the fifth. Depends on how many numbers there are. In this case, there's 4, so we have a remainder, a constant, an x, and an x squared. So that means that these are your coefficients, x squared plus x minus 3.
Thank you so much.
Yeah. And then with a remainder, so plus 4. plus 4 over whatever we divide it by, which is x minus 1. Cool. So without doing all the long division, we can just do that. Cool.
Thank you.
Yeah, so let's just quickly go over these two questions. So letter B, when we go to set this up, we need to put a 1 here, and the first number inside will be 1, and then we need a placeholder for this one because there is no x squared, so we would need a 0 here, and then negative 4, and then 7. We take this, bring it down, and we put a 1 here. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 4 plus 1 is negative 3. And then 1 times negative 3 is negative 3. 7 plus negative 3 is 4. Every single time, this answer here is going to be a remainder, and then you work your way up. Constant x squared. So this answer will be x squared plus x minus 3. And then it's really important for you to remember the remainder is always going to be a fraction. It's going to be plus 4 over whatever you divide it by in the original problem, which you don't even use at all in this process. But you have to remember that it's going to be 4 over x minus 1. And that would be your final answer. Did anyone get to do the next one? All right, I'll quickly go over that one. So letter C, if we set this up, we would need what number here? 3. And then it's going to be 1, negative 1, negative 14, and then 24. We bring this down. 3 times 1 is 3. Negative 1 plus 3 is 2. 3 times 2 is 6. Negative 14 plus 6 is negative 8. 3 times negative 8 is negative 24. 24 plus negative 24 is 0. This one does not have a remainder. Constant x squared. This answer is x squared plus 2x minus 8. So much easier, right? Okay. So tomorrow, you guys are going to be working on